To kick off the project, we performed extensive research into Europa's oceans, which formed the basis of the structure and design for our project. When deciding which materials to use for the base station, we considered those that make the life and work of the scientists easy. We hope to use a gym, a cafeteria, 2 labs, a control room linked to a virtual reality room, and a control room which controls the ventilation systems and the hot water filtration systems. As we plan to keep Europa clean, we think that all the human waste should be used as fertilizer for plants to keep the scientists healthy.
Thin ice model and recent research suggests that Europa's ice shell may be a few kilometers thick. This being provided, the station will house ice-penetrating radars that will send data back to satellites orbiting Earth.
We sort of use the mini submersibles as an excellent auxiliary that will consume little power whilst being able to travel fast and fit in small places. We also have the potential to use VR to be able to control the mini submersible. That will make it more immersive. Furthermore, we can attach sensors to the mini submersible that will be able to measure or detect the chemical composition of the ocean wherever it is and report this back to the submersible.
When choosing how to power our base station, we decided to use a renewable source, ensuring that there's low pollution. We looked at the consumption of existing submarines and calculated that we would need a source that could produce at least 100 kilowatts of power. Initially, we planned to use a tidal stream generator, and we concluded that the velocity of flow would be much too low to provide sufficient power output. We then turned to geothermal power generated from the radiogenic heating of the crust.
Submersibles have arms that are used to collect samples of small microorganisms such as halophiles, ecosilicates, which is a mineral found in Europa's salty oceans and can be mined. The mechanisms within the submersibles themselves are made of bulk metal glass, which is high resistant to cold. The submersibles themselves have thrusters which are ducted to decrease the amount of drag and to increase propeller efficiency. And they're also surrounded by small cages which are used to avoid debris.
The exterior layer of the space station will be made from a thick layer of titanium. Titanium reflects light really well, which increases visibility for incoming drones and submarines. It's also a really good insulator as well, so it prevents heat escaping from the space station. And it's also got a really good strength to density ratio as well.
Ensure that the base is stable construction, as the pressure applied will be distributed around the entire structure. The dome shape proposes the largest amount of volume with the least amount of surface area. The circle shape also reduces the heat loss.
Synthetic foams have very good impact resistance and also have pores that do not allow water to pass through them. It is also a very easily engineered material, which means that we can integrate our sensors. That means that we can detect things like leakages. And also it has very good insulation, which means it's great because it's very cold. And we have low thermal expansion and it's lightweight, which is great because it doesn't put stress on structural materials.
We started looking into submersibles. We started by analysing the hydrodynamics and the shapes that would be involved, as this would help increase the power to drag ratio, therefore allowing for a bigger battery life and faster movement speed. On the front of the submersible, we'll have a 4K high dynamic range and light sensitive camera, which will allow for all visual data that would normally be captured by the eye to be captured by said camera. Behind this camera, we have 2 strips of bright white LEDs that would allow the camera to see up to 20 metres in the deep water. To send the footage back to the home base, we'd be using a nuclear buoyant cable that would allow for faster data transfer speeds than radio waves through water, and also for less data loss. This cable would be tethered on either end by Kevlar tetherings to decrease the chance of anything breaking.